Hi everyone, it's Roman. Today we're going to talk about AIs again, but now in the context of audio transcription and subtitles. For the last couple of weeks, I've been exploring different approaches on how transcription can be derived from audio file, from video file, and in particular for subtitling. You've probably seen videos on Instagram or TikTok, such as this one. But this episode is going to be much shorter because I'm not going to write any code today. Instead, I will pair with ChatGPT and it will do all the hard work, and I will act basically as an interpreter that will be a runtime for the code that GPT is writing for me, right? This is an interesting problem to solve because normally subtitles are just a couple of sentences that are displayed on a screen, right? But to be able to highlight every word as it's being spoken means you need more precise mapping of textual information onto audio. And mapping here means that information in the text file, in transcription, should be enriched with timestamps of audio in the file that was transcribed, right? Before that, let's talk about transcription and subtitles in general. So it's not news that you can transcribe an audio file, right? If you're on a Zoom call or on Slack huddle, you can actually not only record a video, the audio itself, but also request to generate transcription for you, which is going to be just a plain text. And it's really useful because you don't have to record the entire video, which is going to be like hundreds of megabytes or even maybe gigabytes. It's going to be a small couple kilobytes text file that you can actually then store somewhere or even search it, or it's your knowledge base. You can use this information however you want. And then transcriptions can be also used to create subtitles, right? And subtitles is more interesting than transcription because it's no longer only plain text itself. It's plain text together with timestamps, and those timestamps has to be more or less precise because they need to map textual information back onto the audio as is being played, right? Because subtitles are used together with videos. So you have to synchronize basically text and video content or audio in this case. But in order to create like this effect of highlighting every word as is being spoken, it means we need more precise timing in a transcription, which means not timestamping sentences or phrases, but timestamping individual words or maybe even characters, because that's possible as well. And since we're talking about AIs, one obvious candidate for experimentation is Whisper model from OpenAI. It's a model that is able to take the audio file and spit out a string of text, and it works across multiple languages. So if you used OpenAI's Whisper API, you get back text. I'm actually not sure if it gives you back timestamps or not, but since it's open source model, you can run it locally, you can run it in the cloud, and if you use the API, the Python API directly, the output of transcribing function will give you back also a data structure that includes all timestamps. And timestamps in Whisper are per word, so it's a word level transcription. But the problem is that Whisper was trained on half-minute long audio clips, which means if the audio gets longer, for example, like this episode is definitely longer than 30 seconds, right? So the timestamps will be shifted, like because the model will hallucinate and it's not going to be precise. So this means there is still some synchronization needed. And in general, this process of taking a transcription and synchronizing it with audio is called forced alignment. So basically, if you want to produce timestamps, you need forced alignment. The first step would be to derive transcription from audio. And the next step is to map transcription back onto the audio and derive those timestamps. There are many ways how forced alignment can be achieved, but one in particular that I liked and explored is a project called Whisper X, which builds on top of Whisper, and It still uses Whisper, it still leverages information that Whisper outputs, but it's also using a phoneme model from Meta, which is called Wow2Vec. It's basically producing vector embeddings from audio files. And because it's a phoneme model, it knows about characteristics of human speech. Information that can be retrieved using this model from the audio file can be used to align back to basically correct the error which Whisper is including in timestamps. And the results are amazing. Like, you can have word level timestamps, you can even have character level timestamps, and they're super precise. And this information is more than enough to create a word level highlighting or in subtitles. All right, now let's take a look how both Whisper and WhisperX work. How can we use them in practice? It's really like installing them is as easy as running a pip install command, and for both OpenAI Whisper and WhisperX, it will install a Python package which can be used as CLI and of course from Python code. And WhisperX CLI is exactly the same as OpenAI's Whisper. It has the same set of options. So I have a test audio file, which is a 20 seconds audio from the clip that I showed in the beginning of the episode. This episode is going to be much shorter because I'm not going to write. It's the same audio. So we're going to try with a small model because it will be fast, but for this clip, it's enough. So let's run Whisper first. It's going to take some time. It has to load everything in memory and start things out. All right, now it's done. You can see that it printed some subtitles, right? But it also generated different form of subtitles in different formats. So we'll take a look at SRT for example, and you can see that it's basically the same what it printed in terminal. There's a couple of sentences, 3 of them, and each of them has timing, right? So it's not word level timestamps yet. And if we open JSON, okay, so it's a data structure that represents the output. It's kind of the same. It's a sentence and then start and add time. Okay. The next one is using Whisper, but now with word timestamps option. Cool. You can see that it printed exactly the same result, but if we open subtitles file now, you can see that we have more lines than before, and every time period is super short, and every word on every line is highlighted with underline tag. So this means when I've generated subtitles with word level timestamps. And also if we open JSON file, we can actually see that apart from having the sentences, we have also word level objects that describe when every word starts and ends. And also probability is like, it's the number from 0 to 1, which means how sure the model was that this is the word that it was, that it tried to guess. Cool. And yeah, finally, let's try WhisperX with word timestamps. Okay, you can already see that WhisperX is doing a little bit more than Whisper. It's chunking audio in the beginning and then transcribing it and then performing an alignment. But yeah, and here we have test word subtitle file, which is kind of the same that was created by Whisper, but now the timestamps here are more precise, and it's not really noticeable on a short clip because it's only 20 seconds, but for longer videos, WhisperX is going to be much better at detecting words. So here we go. That's how you can use both Whisper and WhisperX to transcribe and generate subtitles and get word level timestamps. Thanks for watching this episode. If you liked it, make sure to hit like and subscribe button and let me know in comments what you think or what you're interested in learning next. See ya.